In this video, we'll draw a simple network using PSCAD and we will try to simulate like this. What will be the current waveform, voltage waveform, what will be the active power and reactive power. So let's start. I have created a new workspace, new case study in the same workspace. You can off this grid. So first of all, we need a source. From this master library, we will take this source. Let's say this one. This source we can take model 2. Just copy and paste. I'll rotate this. So for this source, this is the source name. Let's say this is grid. Ideal source R equals to 0. You can change as RLC or inductive capacitive, R in series with RL parallel, like this. So in this case we will consider as ideal source. Single line view, 3-line view. Now it is single line view. If we make it 3-phase view, then it will look like this. In our case, we will consider it as single line view only. Okay. Now we are done for this source. Now we will take one resistance and reactance here. For this resistance, we will take 10 ohm or maybe 5 ohm. And for this inductance, what will be the value of this inductance? We need to calculate. Let's say the X by R ratio, grid X by R ratio is 20. It is given. So this input is available and R is 5 ohm. We have seen 5 ohm. So what will be the value of X? X equals to X equals to 100. If R is 5 ohm, X by R is 20, then R equals to then X equals to 100 ohm. But we need to put the value of inductor here in Henry. So how to find out the value of L? So As we know, x equals to 2 into pi into f into L. X equals to 2 pi f L. So L equals to x by 2 pi into f. So this equals to x is 100 divided by 2 into pi. What is the value of pi? 22 by 7. Let's take the value. Pi is 3.14 into f, means 50 hertz for our 50 hertz frequency. So this is the value of L. This is in Henry. So 0.318. So here 0.318 Henry. Okay, that's done. Now we need to connect by this wire mode. Okay, so this is the line parameter. Now I will add one load here. I'm considering the load as a resistance, and it's the earthing connection. Let's say the value of load I am considering as 5 ohm. Okay, now we'll measure the value of voltage and current here in this location. So what we'll do, we'll put a multimeter here. We'll put a multimeter and connect. Okay, for this source, these are the signal parameters. Here this is the frequency. In our case it is 50 hertz. 230 kV. 230 kV is the voltage, and phase shift angle, voltage angle is 0 degree. Okay, so our simple circuit is ready. Now let's run this. Okay, so there is zero error. That means the circuit is okay, but we cannot see any output here. to see the output, current and voltage. So what we need to do, we need to configure this meter first. Let's say we want to see the instantaneous voltage here, instantaneous current, active power flow, reactive power flow. So these four parameters if we want to see. Now signal name, we need to define instantaneous voltage. Let's say Vs, instantaneous current, instantaneous current, Is, active power P, reactive power Q. Okay. Now to see the current and voltage and power waveforms or the outputs, we need to create that plot. Okay, so for this we need to call this signal. We will take four signals. Put the signal names. Vs, this is for the current signal. Is, this is for active power. P, and this is for reactive power Q. So we'll try to find out these four signals. We'll try to measure by this multimeter. Now we need to take the channel to see the graph. There are four channels. Connect it to wire mode. Now what we need to do, here no need to change anything. Only thing is that this is the voltage, so we can put the unit name here as kV, because in this source it is 230 kV. We'll measure here. This is the current, let's say kiloamps. This is active power, kilowatt, and this is reactive power, kilowatt. Okay, now we need to see the curves, voltage and current curves. So go here, graphics, meters and control, and add overlay graph with signal. Let's run once whether this voltage is coming fine or not. So the software is running now, it is simulating. Yes, now we have got something. Let's reset this and measure the values. So if you closely look, the voltage value is here. You can see maximum 187.794 kV. This is in kV, kilovolt, and minus 187.794. This is the negative side. So this is the voltage, how it is coming 187, because we have put here the voltage as 230 kV, 230 kV. So how this 187 kV is coming? Because 230 kV, 230 kV. Now what will be the phase voltage? Equals to this divided by 1.732. That means root 3. This is the phase voltage. This is the phase voltage, 132 kV. And what will be the RMS voltage? RMS voltage equals to this multiplied by root 2. This multiplied by root 2, 1.414. So 187.771, 187.794. So this voltage is coming fine. Now only the voltage we can see here in this plot. Similarly, we will see what is the value of current, what is the value of active power, and this reactive power. So for this, what we need to do, in a similar way, we need to call the plot here, and now the canvas is smaller in size. We can increase the size of the canvas. Yes, we need to call this power plot. This is for active power. And one more thing, the reactive power, right? Let's say here, this is for the reactive power. Okay, so we are done. We'll run to see the values here. Yes, now this is the voltage, this is the current. Reset and measure. This is the current here, kiloampere. So 1.87 kiloampere. This is the current. Right. Here you can see current for R phase, current for Y phase, current for B phase, and let's say for R phase, you can plot the bold. You can notice the difference here. If you click this bold, then the curve thickness will be more. This is for Y, This is for B or YB, like this. Okay, now this is the active power in kilowatt. Reset, measure. So this is active power 52 kilowatt. This is reactive power. This is the value of reactive power, which is 523 kilowatt. So what we can see from here, this is the voltage waveform, this is current waveform, this is active power, and this is reactive power. Now if you want to plot this uh, in a meter, let's say you want to see in a meter, then you need to consider this control panel here. Let's say this is the control panel, and let's say you want to plot this power, active power. Just control C and control V. And similarly for reactive power, copy and paste here. Now it is showing 0, it is showing 0. Once again we need to run this. You can plot the current value also. This is the control panel. To plot the current, control C and control V. Let's run once again, and you will notice the current waveform. Now it is in 0. Yes, so you can see the current value also using the meter. So this is 52.47 kilowatt. This is the active power P. This is the value of real power P. This is 52.38, 52.475. This is the maximum value. Okay, and this is the value of reactive power. 524 kilowatt. So this is a simple circuit. Depending on the project requirement, you can model this source in a different way. How to do that? Let's say for this signal parameters, if you click here, the external control of voltage, if you choose yes, and external control of frequency yes, then you need to provide, then you need to define this voltage magnitude and voltage angle, frequency externally. So that will be covered in separate video, how to model the source in different ways. But we have considered the ideal voltage source here. This is the ideal source, and this is a simple circuit, and how we have simulated the voltage, current, real power and reactive power. So in this video, up to this, we'll see in the next video.